Good morning. Today we are covering Algebra 2, Lesson 4.3, which is on factoring trinomials. And remember, factoring is basically unmultiplying. It's basically unmultiplying, which means you're really dividing. But as you deal with factoring, you're going to go back and forth, forwards and backwards. So you will sometimes be actually multiplying instead of dividing, as we shall see. So what are you going to be able to do? You're going to be able to factor trinomials by the time you are done with this. And we're going to show you the FOIL method, and we're also going to show you the area method to do these things. And so this video is going to support IXL skills J2 and J3. J2 deals with the area method, and J3 uses strictly the distribution of FOIL. So again, remember, you're taking notes, and you must then put a header on your notes where you print clearly your name, first and last, no abbreviations, no aliases, the date, the period, and the lesson notes name and number. If you're going to email the notes to me, then you must also put that same information that I just said here on your email header. So make sure that you do that if you send it by email as well. Your notes on this video and then upload them. You can either upload them again, either using the Student View Dropbox, or you can email to me, and both of those tasks must be done by 11:59 p.m. Saturday. All right. So the first thing we're going to do here is we're going to go back and we are going to cover basic distribution, which is multiplication. Okay, so we're going to use FOIL for multiplication. FOIL, generally speaking, is for full multiplication. So I want you to remember that. Multiplying polynomials. So we have two factors here. So this is a factor. And this one here is a factor, which when we multiply together using FOIL gives us a product. This is the result or product. Okay? All right, so we're going to just go through and very quickly go through the process of foiling these, or doing distribution by foiling. And remember, foiling, what you're going to do is you're going to multiply first to first. So first to, this is first. And so there you go. And last to last. So there you go here. And then you're going to multiply the outer. So the outer and the inner. Okay, so outer and the inner. It's not as clean as I would like it to show, but so I'm putting these letters under the terms in question. But basically, again, it's first, outer, inner, last. And I'm going to color code first always in blue and last in blue. And I'm going to color the outer and the inner terms in red for the most part when I go through these. All right, so let's just take the problem over here. I've got x, let's use black, x plus 5 times x minus 4. And so I'm going to go ahead and multiply x to x. All right. So x to x, which is the first, I'll just do this once now, is going to be x squared. And then outer to outer. So outer to outer. And that's negative 4 times x, so that becomes negative 4x. All right. And so outer to outer. And then inner to inner. So that's going to be, let's use red. No, let's use this. So outer to outer, inner to inner. So that's this. And last to last. So that's going. So this is 5x. Let's write that out. So that's plus 5x. And I should have done this in red, because I want to keep these together. Okay, and then last to last. So last to last is 5 times negative 4, which is negative 20. All right. So what I want to try to show you here in the red is that the negative 4x and the 5x, those are likes, and you're going to combine them. So what I'm trying to show you is that the outer term is always multiplied to the other outer term. And of course, the last, that's the first. The last term is always multiplied together. It's the terms in the middle, they're multiplied together, but then they're added together. Okay, so that's an important distinction to note. So this is simplifies to x squared, and then minus 4x plus 5x is just x plus x, and then minus 20. All right. So this is a trinomial. Now you can reverse this process, and we're going to do that when we factor, but we are not going to do that now. Let's do this next one over here, and I'm going to just use, again, we'll use FOIL. So x to x, let's just x to x, x to the 7 here, then x to the inner here. Keep wanting to do this a little bit different, but that's all right. And negative 7 to the 7 over here. So let's do that. All right, so x to x is x squared. X to 7 is 7x, so that's positive 7x. And then negative 7 times x is negative 7x. And negative 7 times negative 7 positive times a negative, so that's negative 49. And so if you look at this, you're going to see, okay, we'll bring down the x squared, but positive 7x and negative 7x, they cancel out. These cancel out. So because they cancel out, you end up with x squared minus 49. So let me just bring that over here. X squared minus 49. So that's what you get when you FOIL this. And of course then for number 1, this is what you get. Okay. All right, so then the last one, now this one is x minus 3 squared. So what you have to do with this one, because it's squared, that just means that you're multiplying x minus 3 times itself. So you rewrite this as x minus 3 times x minus 3. And so again, you're going to do the same thing. You're going to FOIL it. So first, let's try to be consistent here. First, outer, inner, now I'm doing it right, and last. Okay, so first is x times x, or x squared. Outer is negative 3x because you got negative 3 times x, so that's outer. And you also have inner. So inner is also negative 3x. So inner, negative 3x. And then last is negative 3 times negative 3, which is positive 9. And that's your last, so you put that, whoops, put that like this. Okay, so then again, you always add together the outer and the inner, and you get negative 6x there. So x squared minus 6x plus 9. Okay, so there is your foiled trinomial. Okay. All right, so that's foiling, that's multiplying together. But what we're doing is factoring. So we're going to go backwards, and when we go backwards with foiling, instead of multiplying our polynomials together, we're dividing them. But we're still going to kind of use FOIL as a device when we do this. But before we get to that, what I want to do is use algebra tiles, and this is the area method that we're talking about. Algebra tiles are, they're just tiles that are used to represent the area that's formed by two binomials. When you multiply binomials together like this, you get squared units. And squared units is how you come up with area. So if I say that I have a length of 5 and a width of 6, then that's 11 times 6. I'm going to end up with an area for whatever the object is. If it's 11 times, or 5 times 6, 5 times 6 is 30. So you have 30 square units, whatever it might be. So we're going to go ahead and use algebra tiles, but we're going to do it by hand. So I don't have algebra tiles, but we're going to kind of make some. So I'm just going to sketch a few algebra tiles here. Where's my pencil? Here it is. This is the pair of binomials that we're going to multiply together using this. So again, remember this is multiplication, and so this is kind of like 5 times 6, when you set this up. So the tiles are going to look kind of like this. So I'm going to just sort of quickly come up with a tile here. And I'm not really worried too much about the actual length of it. I'm just coming up with something that looks sort of like this. And so this is a tile that has a length of, or a height of 1 unit, or width of 1 unit if you want to call it, or length. It doesn't matter which you call length and which you call width. But we don't know what, now I guess we'll call this width. We don't know what the width is, so we just call it x. It's some unknown. So this tile is worth 1x. All right? Now, if I take one of these tiles and I go ahead and draw it like this, this is approximately right. So that's 1x. And I take another one. Let's see if I can get this approximately right. And if this is 1x, okay, then the area that it represents inside is x times x, or x squared. Okay? So in this case, we have, well, let's multiply this together. We have Well, let's see. We have 2x's plus 3. So I've got 1x here. So I need another x. So I'm going to put another x in here. Approximately, right? So now I have 2x's. And then I want 3 units. Now 3 units, what I use instead of this, I'm going to use something that looks like this. So it's 1 times 1, or 1 unit. Okay. So I'm going to get 3 of these on the top. So 1, 2, 3, right? So they're each 1, 1, and 1. Right? And then, so let's see, we can then go down the, so this is, what does this represent? Again, it's 2x plus 3. Okay, that's what all this represents here on this line. So consider this kind of a line here. Okay. Now down this side of our box, we're going to do x plus 2. So here's an x. So then we want 2 single units. So 1, 2, roughly. Okay. So those are 1s and 1s. Okay. So that's x plus 2. All right. Okay. So we have the 2 binomials represented in this picture. Now I'm just going to kind of extend this box. Okay. So now I want to fill in, I got 1 here, but I want to fill in this here. This is, the length of this is going to be 1x. So if you look at it, I'll fill it in with 1x. Why? Because I got a 1 over here and I got an x up here, so this is 1x. And then I'm going to do the same thing down here. 1x. Because I'm multiplying 1 times x, I get 1x. The same thing going on here. Now in this case, the first one, I've got an x here and I got an x here. So x times x is, again, x squared. So I've got another square here, roughly. No, I'm a little bit off. And then I've got 1 here and an x, so that's another 1x. And I got another 1x down here. Okay. All right. So now, how am I going to fill this up? Well, I've got 1 here. And then this is x. So 1 times x is 1x. So I'll put another one of these long, skinny boxes in. Okay, so that's 1x. And then same thing here. So 1x. And the same thing here. 1x. So then what do we do down here? Well, these little boxes, I mean, this is 1 times 1. 1 times 1. So I put a little box in there. This is 1 times 1. So 1 times 1, put a little box in there. This is 1 times 1. 1 times 1, put a little box in there. Then this is also 1 times this one down here, so that's another little box. 1 times this box over here, 1 little box. 1 times this box over here, 1 little box. So 1, 1, 1, 1, 1, 1. And so you'll notice you come up with this rectangle, okay, which is your area. So here is a representation of the area. Now you say, well, what does that get me? Well, what we're trying to do is we're trying to go ahead and figure out, you know, what would be the ultimate product of the multiplication of these two binomials together. Can I get it from this? Well, the answer is yes, I can. Because I've got, let's see what I got. I got 2x squareds, so I'm going to write 2x squared. And then I've got how many of these x's? 1, 2, 3, 4, 5, 6, 7x. And then how many of these little singletons do I have? I got 1, 2, 3, 4, 5, 6. 6 singletons. Now, you don't believe me? Well, you could FOIL this. So if I FOIL it, 2x times x is 2x squared. 2x times 2 over here is 4x. 3 times x is 3x. And 3 times 2 is 6. And then, of course, these two you add together. So you end up with 2x squared plus 7x plus 6, which is just exactly what we got by looking at this box method. So this box method is a cool, way cool method. And it's really best when you have trinomials that have a number other than 1 in front of the x squared. I mean, you can do it with any trinomial. So any two binomials you can multiply together using this method. In fact, with a monomial and a binomial, or a monomial and a trinomial, you can use this method. With a trinomial and a trinomial, you can use this method. You can use this method with the multiplication of any pair of polynomials, no matter how many terms they've got, using this method. Okay, it'd make a great big picture if it was a high polynomial, but you could do it. So this is a real way cool way to do things. Okay? All right, so you're going to be doing this in IXL, but IXL shows it a little bit differently. I think it's the, is it J2? Let me see. Yeah, it's in J2 that you're going to see this. So here's an example. This was taken from IXL. So what they do is they say, okay, which area model represents the factorization of this trinomial into this pair of binomials? So again, factorization means you are dividing this trinomial back into these two binomials. Now remember here, we were multiplying together to multiply. But you can also use information from this when you go into factoring. So, all right, well, if we were using the box method, then we would know that we would have to have the top here, or one part of it being x plus 3, and the bottom, or the side being 2x plus 2. Or, you can switch these. One could be, this could be the top and this could be the side. So let's see what we got. Now, I'm not going to worry about trying to do that, figure out which side is which and what are we going to do. I'm just going to simply look at the number of x squares, the number of x's, and the number of ones we have. So this thing says 2x squared. Okay, I got 2x squares right here, so that's a candidate. Here I only have 1x squared, so that's not a candidate. So I would just, now in IXL you couldn't do this, but mentally I would just kind of put a line through it. This has 2x squareds, so this is a possibility. This one has only 1. Now I need 8 x's, so I need to count these. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 x's. So this looks like the winner, but let's count these. 1, 2, 3, 4, 5, 6. Yeah, this is only 6 x's. Just to be sure, count the units. 6 units? Yep, we got 6 units. So that's your answer. That's how you would do it. And you would click on it and they'd say, oh, outstanding job. Okay, so now let's use tiles to go ahead and do the factoring. Okay? All right. So, all right, what I got here? I got 2x squares. So I'm just going to draw. Let's use something a bit darker. I'm going to draw a couple of boxes. Here's an x squared, and here is an x squared. Okay. So I now have two x squares here. Now I need 7 x's. That means I've got to have 4, probably 4 and 3, because you'll notice I have 3 over here. That means I'm going to have 3 singular units. So let's do it this way. I've got 7 of these. I could break it up into 3 and 4. I could break it up into 6 and 1. But I got to get 3. So I can only, to get 3 here, I would have to have probably the 6 and 1. So that means I'm going to have 1x here. Let's just see if it works. 1x here, so those are 2 x's. 1x here, 1x here. So that's 4 x's. 1x here, 1x here. Okay, so that's 6 of these. I need the 7th one. I'll put it over here. Now, the reason for my thinking on this is this is 2 rows of 3 x's. So if I have 3, I want to do them to create a box. I would just put them over here under the 1x, and I'd form a column of 3. And so now you see you've got a rectangle formed. And that's what you always want. You want your rectangle filled. So that would be how you would do this. And the only thing I would add to it is I would put the little ones here. And I would also say, okay, this is x squared, and then there's 1x. So x squared plus x is what's up here. And down here on the left, I've got an x squared. Oh, I'm sorry, that's 2x squareds. 2x squareds plus x. And then down on the left here, I would have, let's see, x squared plus 3x. Okay. Now I'm only taking what's on the side, okay? And this is a trinomial. A trinomial is usually made from 2 binomials. So that sounds about right. Let's just double check it. 2x squared plus x and times x squared. Oops. This is not x squared. I'm sorry. This is 2x. Okay, let's jump back. I did a boo-boo. So I'm going to use my handy dandy whiteout. Sometimes we get carried away and we don't think straight when we're just doing these. Okay, so it is true that this is x squared because this is an unknown side and this is an unknown side of the box, right? So x times x is x squared, and we got 2, but what we have here is this length on this side is x, and this length on this side is x. So thinking of it that way, you know, this is x, and that forms the x squared, okay? So, but on the top, it's just the length of x, and this is the length of x. So we have 2 x's, and then over here, well, this is 1x, right? So since it's 1x, on the top, it's just 1. So this is 2x plus 1, and this is, get my little white out again. This didn't quite disappear on me. And this is x plus, again, this is 1x here. So 1x, these are each 1x. So it's 1 on this side, right? So there's 3. So you end up with, let's just get rid of this. You end up with 2x plus 1, right? Times, down here it's x plus 3. And again, if you don't believe me, multiply back together using FOIL. 2x times x is 2x squared. 2x times 3 is 3x. I'm sorry, 2x times 3 is 6x. 1 times x is 1x. 1 times 3 is 3. And then, of course, these are likes, so you're going to add them together. So you'll have 2x squared plus 7x plus 3, right? And so that's exactly what we had when we started. We're in good shape. So again, you can use these tiles by just taking the 3 terms, putting the x squared tiles down, remembering though that the x squared tile sides have sides of x times x, and the x tiles are 1x, so they have a side of 1 and a side of x. Set them up like that, and then the little singleton ones, they're 1 times 1, so their sides are each 1. And then you can figure this out. You've got an x, you've got 1, 2, 3, so x plus 3 on here, this side, and then 2x plus 1 because you've got an x here and an x here and a 1 here on the top. Okay, so that's really it for the area model. It's a cool model. You can use it either to multiply 2 binomials together, or you can take the trinomial that you're given and set up the tiles again, the picture, pick out what the information is to come up with the 2 binomials, which you would put along the sides again, one on the top, one on the left-hand side. You're good to go. All right. Okay, so that takes us through algebra tiles. Now what we're going to do is we're going to factor trinomials. Now, in this case, how are we going to do this? We're not going to use factoring or algebra tiles. We're going to factor the trinomial. So let me restate that. Factoring the trinomial. And so we want to get it into the standard form here. I'm always reminded when I think of factoring. I had a friend who was also a math teacher, and he used to sing to his students, factor, 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 factor like it's hot. Factor, 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 even when you're not. So anyway, kind of silliness, but always puts me in a good mood when I start factoring. So factoring, remember, again, is taking apart. So we're unmultiplying. This is unmultiplying, which just means to divide. You're dividing a trinomial into 2 factors. So this is a trinomial, and the way you factor that trinomial is you basically do what we call, or what I always call, reverse FOIL. So what we do is we set up a double bubble, for those of you who speak Spanish, double bubble, 2 parentheses. And so I'm going to set up 2 parentheses here. And I'm going to populate that. So remember, with FOIL, you want your first, you want your last first, your first and your last. Okay. So with the first is x squared. So if you divide that, x squared divided by well, it's going to be x times x. Okay. And then, so then you have the last term that you're going to deal with. So you're going to find, in this case, you want to find factors of 24 that when combined will equal the middle term's coefficient. Okay? So we want the greatest common factor of 24, the third term, which is the c. Okay? So greatest common factor of c. Just showing you where it comes from, where it's going to. So let's see. I want them to add up to -2. So I've got, I don't know, 6 times, well, this is negative, so 6 times -4. 6 times -4. Well, isn't 6 and -4 +2? Well, and then how about -6 times +4? That also equals -24. -6 plus 4 is -2. So it's -6 plus 4. Okay. So it doesn't matter which order you put these in. You could put the 4 over here and the -6 over here, because when you multiply it together, it's okay. But always check it. Now, I've had some of the other, one of the other teachers actually in this math department who is very knowledgeable. She likes to create what she calls a rainbow. She says, okay, you're going over here first to last, and then you are going to check the outer and the inner. And so what she does is she says, okay, we know that -6 and -4, when they come together, they got to equal -2. Okay, and so she will say, all right, let's see here. So I've got -6x and I've got +4x. So she'll say, all right, -6x, +4x, add those together, and it equals this, -2x. So she's checking this, okay? She calls it a rainbow because she sets this up in a little rainbow, which is kind of fun. But all we really need to do is to take, again, the multiplication of -4x and -6x, because that's what we're doing here and here. So these two here. And she'll put it up above here, but it interferes with what I'm seeing a lot of times, so I don't. She just takes the 4x and the -6x, she combines them together, and she comes up with a 2x, and she knows she's got it correct. You can also FOIL this back together and come up with the same deal. All right, let's take a look at this second one. So we're going to do the same thing. We're going to go ahead and FOIL this, or reverse FOIL it, if you will. So we're going to look at the first, and we're going to look at the last. So the first is x squared. So x times x is x squared. Right? And then the last is -18. So we want a greatest common factor of -18. It is, which when added together comes up to be +7. So that sounds like, well, it could be positive or negative numbers, or negative and negative numbers. And so when you aren't sure about this stuff, you can start out by just multiplying 1 times -18. That's that's -18, but it adds together as -17. That doesn't work. Then 2 times -18, I'm sorry, 2 times -9 is -18. And so when you add together 2 and negative 9, you get negative 7. Well, this is positive 7. So how about negative 2 times positive 9? That also equals 18. But when you add them together, negative 2 plus 9, you get 7, right? Which is what you want over here. So these are your two factors, 2 and 9. So plus 2 plus 9. And then, again, you double check. You take your 9x and your 2x. Oops, wait a second. Not 9x. Yeah, it is 9x. This is negative 2. That's where I went wrong. So my 2 is negative. So this is negative 2. So 9x and negative 2x. You add them together, and by golly, you get 7x. So that means it works. And again, you can FOIL this all together and multiply the two binomials together. X times x is x squared. X times 9 is 9x. Negative 2 times x is negative 2x. Those add together 7x. And then negative 2 times positive 9 is negative 18. So that's what you would do. All right. We'll try to go more quickly through these last two. So we're going to do the same thing. We're going to use the first and we're going to use the last. And so x times x is x squared. And now we're going to look for greatest common factors of 36, which when multiplied together are 36, but when added together are negative 15. Well, that means we're going to, if we're multiplying two numbers together that end up with a negative result, when you add them together, that means you're multiplying together two negative numbers. So like negative 1 times negative 36 is positive 36, and then we get negative 37 as a result, which is not what we want for the middle one, but it's still negative. So let's use negative terms. Let's think of something closer together. So let's see, 3 times 12 is 36, and then if they're negative 3 times negative 12 is 36, negative 3 plus negative 12 is negative 15, yeah. So negative 3 plus negative 12 equals negative 15. That's what we want. So we're going to use negative 3 and negative 12. So negative 3, negative 12. Again, check the middle here. X times negative 12 is negative 12x. And negative 3 times x. Negative 3 times 12 is 36. This is 12 for 15. Yeah. Okay. X times negative 3 is negative 12. Negative 3. Yeah, okay. I just sometimes get these mixed up in my head. So add these together and you get negative 15. Okay. All right. Last one. So same thing. We're going to look at the first and the last, which we're multiplying together. And so x times x is x squared. And the last is we're looking for, again, the greatest common factor of 18 that when added together equals 11. So these are both positive terms here. So that means our factors are going to be positive. So let's see. 6 times 3 is 18. 6 and 3 is 9. Let's see. 18. 2 times 9 is 18. 2 times 9 is 18, right? And 2 plus 9 equals 11. So that's what we want, 2 and 9. Plus 2, plus 9. Now let's check these. So I've got 9 times x is 9x. 2 times x is 2x. You add together 2x and 9x, and by golly, you get 11x. So you see how this works. Now, The big thing about this that makes this easy is that your first term, your squared term in each of these cases, is just 1x squared. If you have a coefficient other than 1, then in the first term, and of course you see you have numbers in the other terms, then you're going to want to see if you can't factor out any greatest common factor out of all three terms before you actually go through and do this method. And so that's what we're going to see in this next one. So over here we've got 2x squared plus 18x plus 40. So if you look at this, I've got a 2, an 18, and a 40. You can divide a 2 out of all these. So I'm going to divide 2 first. So look for the greatest common factor first and divide it out. That's what we're doing here. So 2 divided by 2 is 1. So now this 2 doesn't disappear. You put it out here in front of your binomial double bubble you're going to do. Now we're going to do the double bubble thing. So I'm going to write, let me see here. I'm going to write, trying to put that underneath. Let's see here. Yeah. So 2 divided by 2, it leaves me with x squared, right? And let's just do it this way. Let's reduce this to a trinomial. So I'm going to divide out 2 from 2x squared. I'm left with x squared. And I'm going to divide a 2 out from 18. So 18 divided by 2 is 9. And then I have x's, 9x. And then 2 divided by 40 is 20. So I have 20 there. So now I'm going to FOIL this trinomial here. Okay? So I've got the 2. You can't forget it. You have to leave it there. But you're now going to have two bubbles here, or parentheses. And this is your first, and this is going to be your last. So your x times x is x squared, right? And then your last, your greatest common factor of 20. I want two numbers that multiply together equal 20, but when added together equal 9. So, 2 times 10 is 20, but you add them together, that's 12. 5 times 4 is 20. Okay, here you go. 5 times 4 equals 20. But if you add together 5 plus 4, you get 9. So that's what you want. It's 5 and the 4. So plus 5 plus 4. All right? And then again, you can check this. 4 times x is 4x. And 5 times x is 5x. So they add up equaling the 9x. So this is your completely factored form of the above trinomial. Don't forget the 2 out front. Okay? All right, let's do B. Same thing. Let's look for greatest common factors. Aha, we got the -3 here, we got 33 here. And let's see, I think 54 can be divided by 3. Let me check my calculator. So let's clear this. Well, let's use -54 divided by 3. Yeah, -18. So we can easily divide and since I've got a -3 here, I'm going to divide -3 out of all 3 of these. You always take the negative out if you can do that. Okay? Out of the first term, that is. So I'm going to rewrite this as -3 times, and I'm going to do my trinomial. But first I'll divide out the -3. So -3 divided by -3 is 1, so I end up with 1x squared now. And then -3 divided by 33 is -11, and then this is, I should have done this as, well, let's change this to an x. Okay, so 11x, okay? And then 54 divided by 3, -3 we said, and it's negative divided by negative. That's positive 18. Because we checked it before, it said -18, but I was thinking that the 54 was positive, and then we had the -3, but 54 is negative, so negative divided by negative is positive. All right, so now we factor this. So we've got negative 3, and we have first, and we have last. X times x is x squared. And so greatest common factor of 18, that when added together is negative 11. All right, so this looks like I'm going to have a negative number here. Let's see, 2 times, I'm going to have factors that have at least one or both are negative. Probably 1. So 2 times 9 is 18. And 2 and 9, 9 and 2 are 11. Okay, so how about, and we want negative 11. Okay, so if you want negative 11, you have to be able to add together 2 negative numbers. You need negative 2 and negative 11. Okay, so negative 2 times negative 11, negative divided by negative is positive 18. So that gets you this. Negative 2 and plus negative 11 is not 11, I'm sorry, 2 times 9 we said. Negative 2 and negative 2 times negative 9 is negative 18. I said it right, spoke it wrong, or wrote it wrong. So negative 9. Negative 2 times negative 9 is positive 18. Negative 2 plus negative 9 is negative 7. Okay, now we got it straight. So then that means I'm going to use negative 2 and negative 9. All right, so let's check that. That means I'm going to take the inner and the outer and the inner. So I got negative 9x and negative 2x. When I add those together, it adds up to negative 11x. So it checks. All right, one last more here. Looks like I got a common factor. I can divide 4 out of 20. Let's check negative 96. Good bet that we can. So negative 96 divided by 4 is negative 24. So we can divide out 4 out of all these terms. So I'm going to put the 4 over here. And remember when we were dividing it out, we just put it on the outside of the bubble of the parentheses here. But up here, divide by 4, divide by 4, divide by 4. 4 divided by 4 is k squared. And remember, and let's set this up as a trinomial first before we try to do the 2 bubbles. So k squared. And negative 20 divided by 4k, I'm sorry, negative 20k divided by 4 is negative 5k, all right? Because negative 5 times 4 is negative 20. And let's see, negative 96 divided by 4 we said was negative 24. So there's our new trinomial. Now we're going to go ahead and break it into 2 binomials. So we're going to look at again the first, and we're going to look at the last terms. K squared is k times k, and then we're going to look for the greatest common factor of, now this is negative 24. It's the first time we dealt with a negative number, and it's going to be negative 5. So if you're multiplying together 2 numbers to get them negative, one has to be positive. Okay, so one's positive, one's negative. So let's see, I want, let's see, negative 6 positive 4 is negative 24. Negative 6 and 4, though, are negative 2. That doesn't help us. Let's see, negative 3 times 8 equals negative 24. Negative 3 plus 8 is 5. So how about we change that around to 3 times negative 8, equals negative 24. And so we've got the negative 8 here and the 5. We combine those, we get negative 5. So that's what we want. K plus 3, K minus 8. Okay. Double check. We multiply again the outer and inner terms. So outer, negative 8 times K is negative 8K. Inner is 3K. We add negative 8K and 3K, and we end up with negative 5K. So it checks out. All right. So this is our answer here. This is our answer here. This is our answer here. Okay. Make sure you get that greatest common factor. That's the first out there. Don't forget them. Otherwise, you will get the problem wrong. All right. I know this is long. Here's the last one. So these are special trinomials, and they're going to be the same kind of situation. So we're going to try to go through these as quickly as we can, but they're special only because some of them, like this one, are, two terms. So first one I've got is negative 3k minus 14k plus 8. So let's see, can I divide out 3 out of those? Doesn't look like that. Make sure I wrote it down right. Yeah, so I've got to do something a little different here. I've got to put, I've got to do 3 and 1, 3k and 1k. So that's a little different. So let's see, 3k and 1k. All right. Okay, so now I want to come up with greatest common factor for 8, and when I multiply those together, I've got to come up with whatever this negative 14k is. Okay, so 8 times 1, well, 8 times negative 1 is negative 8, okay. No, I'm sorry, 8 times 1 is 8. Let's do this right. 8 times 1 is 8. And 4 times, well, let's see. And then when you add those together, that's just 8, so that's not going to do anything for us. 4 times 2 is 8. So what we're going to do is we're going to go ahead and treat this specially later, and the reason I'm looking at this is I'm looking at time. I'm going to deal with this one in class because I want to show you how to do it. It's just going to take a little extra time. So let's just wait on this one. Okay, and let's look at these. So let's see what we got here. Can we take a 2 out of... we got the same problem with this one. Okay, so let's look at this one here. This one we can deal with. All right, so we can divide a 4 out of all these. So divide by, no, not a 4, because we have 10. But 10, we can divide a 2 out. So we can divide a 2 out, can't we? All right. So let's try that. So we divided 2 out, we get 2 times g, well, let's see, this is going to leave a 2 up here, so 2g squared, all right, plus, this is 9g, and this is negative 5, all right, so we got a trinomial there, and so we're going to need to come up with, again, the proper factors here. So we've got 2g plus, and let's see, we want a greatest common factor. Can we do greatest common factor? So we got, like up here, we're going to have problems with greatest common factors. So we've got, I don't know, -9 and 1, and so we're gonna leave these. I think we're gonna leave this. Let's just do the last one. I'm gonna take care of these as a separate thing for you guys, because this I want you to make sure you got it right, and we're running out of time. But this one is easier. So this is what we call the difference of squares. So everything is squared here, and so you've got these two terms. Everything's squared. 4, you can take the square root of 4. 2 times 2 is 4. You can take the square root of d squared. That's d, and you can take the square root of 9. That's 3. So basically all you do is take the square root of each. You got 2d, right? And 2d. 2 times 2 is 4. d times d is d squared. And then over here, the square root of 9 is 3, but got a negative sign, so -3. And positive 3 give you -9. So you have to have negative and positive. Now, just to make sure you did it right, let's multiply these back together. D times d is 4d squared. 2d times 3 is positive 6d. -3 times 2d is -6d, right? And then -3 times positive 3 is -9. And then what happens then is the two terms in the middle cancel each other out. And so you're left with 4d squared minus 9. So this is the correct factorization for the difference of squares that you see in this particular area. So I'm going to treat these separately. I'll just do a very quick, I may even do just a very quick video on these 3. And we'll get those done on the side. All right. So we are done, and I'm going to go ahead and close for today. Thank you.